Hi, good morning to everyone. My name is P.Pavan Sankar Sai from CSC department. Today, my topic is about separation of liquid mixtures, an important concept in chemistry with wide industrial and scientific applications. Let us move into the topic separation of liquid mixture. The introduction to separation of liquid mixtures. Separation of liquid mixture refers to the methods used to isolate individual components from a mixture of liquids. This is extremely important in industries like pharmaceuticals to obtain pure chemicals and medicines, food processing for extraction of flavors, oils, and beverages, chemical manufacturing to refine and pure raw materials. In simple words, we can say that separation helps us to achieve purity, quality, and safety in various products we use daily. Now, let us discuss about types of liquid mixtures. These are mainly generally divided into two types: homogeneous mixtures, heterogeneous mixtures. Let us discuss about homogeneous mixtures. The composition is uniform throughout. Examples we can say alcohol and water mixture. It is homogeneous mixtures are likely a solutions. Heterogeneous mixtures. The mixtures contains visible layers or phases. Example, oil and water. Heterogeneous mixtures contain visibly distinct layers or phases. Uh, it can be here we can discuss examples as fruit salad. It is a solid in type. Vegetable soup, it is liquid in state. Fog, it is gas in state. In this method, the separation depends mainly on the types of mixtures and physical properties of the liquids involved. Now, simple distillation. Simple distillation is one of the most widely used method. It works when the liquids in the mixtures have significantly different boiling points. The mixture is heated, then the liquid with the lower boiling point vaporizes first, then the vapor is condensed back to the liquid and collected it back. Example, purifying water or separating alcohol mixture. This method is simple but effective for basic purification. This is the process of simple distillation. Now let us discuss about fractional distillation. Fractional distillation is used for mixtures with close boiling points. When the boiling points of liquids are close to each other, simple distillation is not enough. For such mixtures, then we use fractional distillation. It is used in fractionating column, which increases the efficiency of separation. This method is widely used in the petroleum industry to separate crude oil from into petrol and diesel, kerosene, etc. Now let us discuss about evaporation and crystallization. These methods are ideal when we want to recover a dissolved solid or concentration a solution. Evaporation. Evaporation is used to remove a solvent by heating. Example, we can get salt from seawater. Crystallization. Crystallization is the process after evaporation is done, pure crystals forms on cooling. This gives a high pure solid, often better than simple evaporation. These are slow process but are very useful in chemical laboratories. Both techniques are useful for concentrating or purifying liquids. Now let us discuss about descentation and separation funnels. These methods are used mainly for immiscible liquids, liquids that do not mix. Descentation involves carefully pouring off a liquid layer from a mixture. It is useful when the density difference is high. Separation funnel. Separation funnels allow for the separation of immiscible liquids using gravity. The heavier liquid settles at the bottom. The mixture is poured into the funnel. By opening the stopcock, the lower layer is drained out. Example: separating oil and water. These are simple gravity based techniques. Chromatography in liquid separation. Chromatography is a modern and highly effective method. It separates components based on their movement through a dictionary medium and on their movement through a medium. It is highly effective for analyzing complex liquid mixtures. Different compounds travel at different speeds, used for complex mixtures, especially for analysis. These are types are included: thin layer chromatography and column chromatography. This method is widely used in research labs and industries. Factors affecting separation techniques. Certain factors greatly influence the efficiency of separation. Temperature and pressure, boiling point differences of liquids, solubility of components, nature of the mixture, homogeneous or heterogeneous. Proper selection of methods depend on the physical and chemical properties of the components. Optimization of conditions improves purity and yield. Understanding these factors helps us to choose the correct method and achieve the desired purity. Applications of liquid mixture separation. Separation techniques are vital in producing pure medicines and chemicals. They are used in wastewater treatment to remove contaminants. Food industry employs these methods to extract flavors and ingredients. Separation techniques are used in various fields like pharmaceuticals, producing pure medicines, chemical industries like refining chemicals, wastewater treatment, food industry, petroleum industry, etc. They play a vital role in improving productive quality, safety, and environmental protection. Now we can conclude that the separation of liquid mixture involves different physical methods such as distillation, evaporation, descentation, and chromatography. The choice of method depends on properties of the liquids such as boiling point and solubility. These techniques are essential not only for scientific research but also for the industrial production and environmental management. A clear understanding of them helps us to appreciate how everyday products are made safe and pure. Mastery of these methods is crucial for scientific, industrial, and environmental applications. Thank you. This is the topic on separation of liquid mixtures.